Autoline After Hours is brought to you by Bridgestone, your journey, our passion, and by Hyundai. See what makes Elantra so nice. Check out its style, interior space, fuel economy, and popular features now.
This is Autoline After Hours with John McElroy, episode 264. For October 31st, an update on Achates' revolutionary engine. Watch Autoline After Hours live at Autoline.tv every Thursday at 6 p.m. Eastern Time or 2200 GMT. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or by following the links on our website. Gary Vasilash, great to have you back here.
John, good to see you.
Good to be here with you.
So I just want to make the point that I'm not dressed up for Halloween. I had an interesting lunch today. You had an interesting lunch yesterday. We'll talk about that later.
We'll talk about our lunches later,
but,
yes.
So good to see you again.
Yeah.
Be back.
And Lindsay Brooke from SAE International is in the room with us, too.
Hey, John.
Good to have you.
Gary.
Right. Lindsay. And, of course, we got Lindsay in here to help us interview our special guest today, David Johnson from Achates Power, and it's great to have you back with us, too.
Great to be here. Thanks very much, John, for having me. Really appreciate it.
So we'll remind everybody, you were here, what, a couple of years ago?
I think it was just a year ago.
Just a year ago?
Yeah, I think it was just a year ago.
Okay.
Yeah.
And we were talking about this wild engine design that you guys have come up with. And just to refresh everybody before we get into where it's all been since you were last here, just describe what this opposed-piston engine is all about.
So this is the fundamental. It's opposed-piston. So we put two pistons in one bore. So you get rid of the cylinder head, and you've got two pistons facing each other and moving away from each other in one bore.
So hold on, Ben, I know you've got some video animation of this. Why don't you run that, and David can talk to that.
So a whole bunch of interesting things happen when you put two pistons in one bore. The biggest thing is you get rid of the cylinder head and the valve train.
Because this is a two-cycle engine.
It is a two-cycle engine.
So you just have reed valves, right?
We have no reed valves. You can see in this video that we actually have ports in the cylinder wall, and there's two sets of ports, one at each end of the cylinder. One set of those ports is intake ports, and that's where the fresh air comes in. The other set of ports is the exhaust ports. That's where the gas goes out. So the air flows through the engine just one direction. It's called uniflow scavenging, and it's actually the best kind of scavenging you can have for a two-stroke engine. It's fundamentally different than your conventional weed whacker engine, which still has a cylinder head and runs a two-stroke cycle, but totally different.
So where's the gas go in?
So the gas goes into a manifold. Each of those ports is then surrounded by a manifold. So you've got an intake manifold, just like you have an intake manifold on a four-stroke engine. You've got exhaust manifolds around the exhaust ports.
So we saw that blue going in, that was air.
It's fresh air coming in.
And gasoline?
No. So the air and the fuel are not mixed. This is just pure intake air. And you close off, the pistons close off the ports. We compress that air mixture, or that air, and then we introduce fuel. We have direct injection.
Okay.
So this is completely different than your carbureted, weed whacker engine or with a reed valve and all that stuff. Totally different. We also have sump lubrication. So this is another thing about two-stroke engines. Everyone talks about two-stroke engines. Blue stream of smoke, right, coming out of a two-stroke engine. That's because they're mixing the fuel and the oil. Not mix the fuel and the oil. Oil's in the sump just like it is in the engine in all our cars right now. And then, so the fuel gets directly injected.
So your efficiency comes from the fact, A, that it's a diesel, B, that you don't have a valve train, and C, that you've got all this tremendous scavenging. Is that essentially it?
Well, I'm going to talk first about heat loss, right? So when you have a combustion chamber, you want all the heat that you're releasing from the fuel to go into providing work to move the parts of the engine, then move your wheels and drive your vehicle. In a conventional engine, the cylinder head is just absorbing heat. Right? It's just a black body. All the heat's going in there. We don't have a cylinder head, so we don't have that heat loss. Right? So basically, you want your combustion chamber to have the smallest surface area, so the least heat goes into it. And when you run an opposed-piston two-stroke engine like ours, we have the smallest surface area to volume ratio that you can get, basically. About 30% less surface area to volume ratio in our combustion chamber than in a four-stroke engine. So that's the primary.
Okay.
Yeah. Then you get the two-stroke. Then you get compression ignition. You get really good scavenging, which we've demonstrated on our engines in San Diego. So basically, our engine breathes really well. So we don't have to put a lot of work into making an engine breathe.
And the engine package would be smaller proportionately to?
Yeah, we find in general, as we size engine to replace conventional engines, that the size of the engine is going to be about 2/3 on a displacement basis of a conventional engine. So if you've got a 5-liter V8, we're going to replace it by something on the order of 3.5 liters. Now that I'm talking diesel. If we start, diesel engines typically are smaller than their comparable gasoline engine. So we did a study earlier this year and presented our results at SAE World Congress, and that presentation was about replacing a light-duty full-size pickup truck engine. So this is a Nissan Titan with a 5.6-liter V8, and we replaced it with a 2.25-liter engine of ours.
Same power, essentially.
Same power.
But much better fuel economy.
Much better fuel economy. Nearly double the fuel economy. So 86% increase in miles per gallon as a result of that, while meeting next generation emissions. So right now we're in the Tier 2 standards, and Tier 3 Lev 3 is coming. We're already meeting Tier 3 Lev 3 with that study. So, and this is all based on the engines we run in San Diego. So we have 2 dyno stands in San Diego, and we run engines all the time and take the data, and then that data goes into our reports.
So what's the nature of the pistons that are going up against each other? I mean, presumably that's got to be far different than conventional pistons.
They are so different. You're exactly right. So we've had people say to us, hey, you're going to have trouble making good combustion in a pancake because you're picturing a flat piston with a flat top, and they come together and they form this kind of disc-shaped volume for your combustion chamber. That's nothing like what we have. Since we have 2 piston crowns that form the combustion chamber, we can shape those piston crowns to complement each other and actually create a combustion chamber shape. So the volume in our combustion chamber where actually combustion happens looks like a football. Looks like a football. And the injection plane of where the fuel comes when we direct inject goes across that football, kind of along the axis of that football. So it's totally different.
As in American football, for our international audience.
Yeah, American football, or maybe even, if you like, a rugby ball. It's that ovalized shape, right?
So the top of the piston head is sculpted downward?
It's a very interesting shape. So we've got a lip on one side, and then we've got a convex shape, the rest of the piston. The other piston looks the same way, and they mate together. So it's very different. It's part of the secret of how we make the engine so efficient, is that actually that shape. So if you looked at that video, remember that video, the air was swirling through the cylinder. So you've got swirling air through the cylinder. The pistons close off the ports in the cylinder wall, compress that charge, and then when the pistons come together, those 2 lips that I was talking about, they create a tumble motion. So we've got swirl, we've got tumble, we've got a lot of things going on with the air charge, right at the point where we're putting the fuel in. And that really delivers the efficiency. We get a very fast burn, very clean burn, low smoke, low NOx, really phenomenal combustion.
So Dave, a lot of John's listeners will be familiar with, like you said, weed whacker engines, motorcycle engines,
right.
Traditional 2-stroke engines, sealed crankcase. How are you doing in sealing that crankcase and sealing the lubricant from the combustion process?
So I would tell you that our crankcase and the lube system is very similar to a conventional engine, right? So you've got an oil pan, you've got a sump basically, you've got the crankshaft spinning above it, right? And then we're drawing the oil out of that and metering it in the places we need it on bearings, main bearings, rod bearings, the places around the engine need to be lubricated. And of course we cool that too. The key difference with other 2-strokes, I would say not just other 2-strokes, there's lots of different 2-strokes, but the ones we're most familiar with are these weed whacker type, chainsaw type, snowmobile type engines where you mix the fuel and the oil. It's called a complete loss lubrication system. It's being lubricated because it's burning fuel.
Right.
We're not doing that.
Right.
That's a recipe.
Can't meet emissions.
Can't meet emissions, right? And the first thing that we went after with our technology was developing the engine, which, post-piston engines have been around for a long time. It's not a new idea. 1930s, they set records for fuel efficiency and power density. Powered planes flying from Germany to Brazil, unrefueled, the Junkers engine, famous results, terrible emissions. So we went to work on solving the emissions. And once we solved the emissions, then we were able to unlock the fuel efficiency benefit. So now we've got a clean engine with fuel efficiency. And oh, by the way, it doesn't cost more. So it's really a great opportunity to revolutionize the industry with a solution that's not only environmentally sustainable and saves fuel, but delivers great performance, fun to drive, and it's very economic. So it's not going to break the bank.
So what are the objections you're hearing? Okay, if this is canned beer, sliced bread,
Well, I told you about some of them. So one of them was you're not going to be able to make good combustion.
Right.
Check that box, look at this data. Right? You're not going to be able to solve oil control. Check that box, look at this data. So we've published all this. So since 2011, we've made 55 technical presentations around the world. At SAE here in Detroit, as well as in Shanghai and in India and in Japan and Europe. So you go all around the world and make these presentations with data that shows we make good combustion. We are thermally efficient. We are clean. We meet NOx and PM and hydrocarbons, and all the emissions are in the box. So the objections are going away. Because, I mean, people came with long lists, but it was always the same list. Oh, it's a two-stroke. It's going to have this problem. Nope, here's the data. So the objections are really going away. And what we're seeing now, and this is really exciting for us, is I've been able to hire a lot of new engineers to join the team because we've got a lot of work to do. You've got customers coming to us and saying, that technology you showed me on that engine, that's really interesting. I want it in my car. I want it in my truck. Show me how it works. And so we're designing engines now for customers around the world for their applications. And each one is its own design study.
Are you looking for light-duty passenger vehicles, or is there opportunity for industrial applications, agriculture, et cetera, because you've got, you know, Tier 4 emission standards on that side, and you've got Lev 3, et cetera, on the passenger side. So I guess, are you meeting these standards with after-treatment?
Yeah. Well, first of all, let me just tell you, we're designing engines right now from 35 kilowatts, so 50 horsepower, up to 3.8 megawatts for power generation. So it's from 80 millimeter and 70 millimeter bore up to 206 millimeter bore, from half a liter per cylinder to 17 liters per cylinder. Right? So we've got this broad range. Basically, anywhere there's an internal combustion engine that needs to meet regulations, emissions, and fuel consumption, or uses a lot of fuel, that's an application for us. So it's broadly applied. In terms of emissions, we have some programs that are looking at using less after treatment because we're cleaner, and others that are using the full-on after treatment like you use in a commercial vehicle or Volkswagen Jetta diesel or any other diesel that's out there. We use that same kind of after treatment.
SCR, et cetera.
SCR, we have a diesel oxidation catalyst, diesel particulate filter, SCR system. But there's some optimization because our engine actually has lower emissions that allows us to lower cost of the after treatment too.
One of the things it would seem to me that a cylinder head does, in addition to being a black
Very
body,
helpful, yeah, right? What is that?
in addition to absorbing heat, is that it attenuates noise. Is your engine noisier than a conventional diesel engine?
So what I would say about noise, the answer is no, basically. Here's what the deal is with noise. Basically, the noise of combustion is primarily due to the pressure rise rate in the cylinder. So it's how fast the pressure rises. And since we're injecting a small amount of fuel into a large air volume, we actually have an advantage with respect to pressure rise rate. So we can tune for faster combustion and not have a higher pressure rise rate. So combustion noise, which has typically been a problem with diesels and now increasingly a problem with gasoline direct injection, where they're facing the same kind of high pressure rise rates, we have an advantage in that regard. So we tune for that. We actually calibrate to have the same pressure rise rates as whatever engine we're comparing against.
How long have you guys been at this engine, developing it?
So the company started in 2004. And we've invested.
So 10 years.
Yeah, more than 10 years now. We had a 10-year anniversary.
So how are you getting your money? I mean, you're talking about hiring more people, doing all this stuff. How do you guys fund yourselves?
Well, first of all, we're very fortunate to have great set of investors that have founded the company in 2004 and continue to finance the company. But the nice thing is we need less and less now because our customers are paying our bills.
And the customers are who? Can you name any or tell us what kind of companies they are?
Good news is I can name two of them. I would love, I would love to name them all. Yeah, that'd be fun, but I cannot do that. The two customers I can name is Fairbanks Morris. So Fairbanks Morris is the company that's been making Opposed-piston two-stroke engines
forever,
for decades.
Navy submarines.
Navy submarines, shipboard. So we have a big Navy installation in San Diego. You can just go down to the shipyard and get on a ship, and there's an OP engine there. There's a Midway Museum that's in San Diego. It's got OP engines from Fairbanks Morris in it. All nuclear power plants in the United States have backup power from Fairbanks Morris engines. So it's a great old company with a great product, but they needed to modernize it. So that's what we're doing for them, is we're basically taking our technology we've developed and applying it to their engine. So it's very, very exciting. The other customer we have is the U.S. military. So the Army has a great need for really high power density, low heat rejection, fuel efficient engines. And so we're doing a project for them right now. It's called the Next Generation Combat Engine. And this is a project that's been going on for about 2 years. Put the engine in the test cell in April of this year. And unfortunately, I can't go into the data, but I can tell you it's a huge success, meeting all the targets. So everything they wanted and more, we've been able to deliver on that engine. And so there's follow-on programs coming. We're real excited about those.
So the first application is basically stationary, and then the second is mobile?
Well, I think you probably want to know.
Submarines don't cost.
Yeah.
I mean,
you probably want to know about production timing, like when can I buy one, right? So what we're doing right now is actually product development work for these companies. Production follows that. So Fairbanks Morris will make their own announcements about when. The Army's engine basically was a technology demonstrator engine, not a production engine. So production will come later.
They probably wouldn't sell me a tank anyway.
Yeah, probably wouldn't be. Might be hard. Might be hard. Might have to do a background check.
So Dave, how difficult is it for a startup company to get into a global industry that has 100+ years of knowing how to do Otto cycle engines, diesel cycle engines? They've got the tooling for it. New guys don't necessarily get in easy, particularly since existing technologies continue to improve as well. Tell our viewers how easy that is, or what a challenge that is.
It is not easy. Yeah, I think anybody who thinks it's easy is a fool, right? It's hard. But I tell you what changes things. So there's two major factors, I think, that play right now that are changing things. One is external conditions, right? We have a need, as we've recognized as a citizens, that we need to clean up the air and we need to save fuel. And so now we have regulations that are driving companies to improve fuel efficiency like never before. And that's in passenger vehicles with our CAFE regulations for 2025. It's in commercial vehicles where we have the first regulations ever in the United States for commercial vehicles, and the next round about to hit us starting in 2018. Right? So these regulations are really driving people to look at things they've never looked at before. The second thing is we bring data. We bring the data that says this engine meets emissions. Come out to our labs in San Diego, read the dials on our screens. You can see exactly what's going on. We measure all the parameters you need to measure, just like any other company, Ford or Toyota or Daimler, you name it. They all measure the same stuff we're measuring. And we have the data. We publish that data, we present that data, and if somebody has a question, we answer that question. And by doing that and being an honest player with good, solid data, yeah, we're winning in the marketplace.
Dave, you talked on your website about the transition to other types of powertrains and hybrid vehicles, electric vehicles, and so on. And you make the point that your approach is more economical. Could you explain that?
Yeah, I think this is a really important point. So there are lots of different ways to save fuel, like just walk. That's one way, right? So there's lots of ways to save fuel.
That's good.
But we need, for us to adopt, or actually solve the problems that we want to solve environmentally, or solve the problem of being reliant on foreign oil, whatever that problem is that you call the problem that you want to solve associated with the use of fuel in vehicles, there's an economic. There are different economies are solving different solutions, right? So electric vehicles have the problem of electric batteries. Lithium-ion batteries are not cheap, and you need a lot of them. I think the other thing that really plays into that is you don't want to change the consumer's behavior. If you go to a consumer and say, hey, you're going to have to leave this car parked here for 6 hours while it recharges, or 3 hours. The reality of what we do with our cars, we use them every day to go back and forth to work, 20, 30 miles, no big deal. But then ever so often, one weekend a month, we want to travel 600 miles in the car. And we've got to refuel it 3 times on the way or 2 times on the way. And you don't want to spend 2 hours, 3 hours, 4 hours. You want the 5 minute that you do. Well, I'm going to run in and get a Coke and get it refueled. But the economics is really a big one because you can see it today in the marketplace. I always like to talk about the Nissan Versa or the Kia Rio or a Ford Fiesta, around $14,000, $13,000 for a very nice car. It meets all the requirements. It's safe, even fun to drive, reliable, clean, crashes. Everything's good, meets all the requirements, right? And then you've got the Toyota Prius. It basically does the same thing, provides the same utility, but it's $22,000, $25,000. So it's like double. So, and then you talk to Tesla, you're up at $70,000. You talk to Volt, you're at $35,000.
But to be fair, if you have a Kia Rio and you have a Prius, you're going to get about 18 miles per gallon more from your Prius than you're going to get from your Rio.
Right, but the first thing you have to do before you fuel your car is you have to buy it.
Right.
So the price of what people buy is very, very important. And you can draw the curve of where people are buying cars and what price is. There's a big, long tail that goes out to the $1 million cars, but most people are buying cars at around $25,000. And so if you want to solve the problems of the world, you have to sell a lot of cars. In the world today, we're doing about 80 million units a year. 80 million units of cars and trucks that get sold to you and me in every country around the world. We want to solve environmental problem. We have to get 79 million of those to be clean and efficient. We can't work on 1 million or 500,000 or 250,000. That won't do it. So we need penetration rates of technologies that save fuel and help the environment that are that 98%. And for it to be 98%, we can't increase the cost of vehicles by $10,000, $15,000, $20,000. Can't do it. And I'll tell you, if you even look at the Toyota Prius, right, the hybrid, the battery in that is the smallest of all the electrified vehicles. And they've minimized that battery because that's the most expensive, add to the car. It already has an internal combustion engine. You haven't taken anything away. So it's all add. You've added the motors and the inverters and the battery and the cooling system for all that and all the power electronics. It's a lot of adds. So, and that Prius is selling very well. but it's the one that's selling very well. I think of the 3% of the market that is hybrids, plug-ins, electrics, all that, 1.5% is the Prius. So it's the one that's selling well, and the other 65 products that fill that market category are scrapping for the rest of that 1.5%. And no one at any OEM is making a good business equation around that.
Looking at your animation, if I was an OEM, I look at bill of material, which to the listeners is the parts count in anything.
Yeah.
Okay.
Take it all apart and lay them out on the ground.
Getting rid of a cylinder head, that's a big deal with all the machining in it. Getting rid of a whole valve train with 2 camshafts, multiple valves, et cetera. Getting rid of any number of other components, but you've got 2 crankshafts in this. What would the unit cost of this engine be on a 200,000 unit per year basis compared to, say, a sophisticated diesel today?
Quickly.
Quickly.
About the same, maybe a little bit less. We take away all that valve train and cylinder head,
right,
but we add in 1 crankshaft and we add in a supercharger.
Okay, we're coming back to this because I want to get into more of these dollar numbers too, but we're going to take a quick break here and give a great shout out to that car company that still has not yet built a car.
Introducing a car company that's never made a single car. We took the power of a 9-year-old V8 and gave it the impressive handling of Firestone's Destination tire. Now, moms agree. Every milk run feels like a victory lap. So whatever you drive a Firestone.
Okay, let's go back to those dollar figures. And so comparable engine to comparable engine, if I'm an automaker, what kind of savings can I expect?
So I think there's 2 key ingredients here we need to talk about relative to our engine. I'm going to make a comparison to another diesel engine. Okay. Diesel engines are already a little bit more expensive than gasoline engines, but as we add, EcoBoost and turbochargers and direct injection, they're coming up, right? They're even talking about cooled EGR and DPFs for future GDI engines. So the cost of gasoline engines are coming up. Diesel engines added all that equipment years ago. So they're already, that gap is narrowing. So I make the comparison diesel engine to our Achates powered diesel engine. Take away the cylinder head, take away the valve train, add back a crankshaft, add a supercharger, and that's about it. Basically, everything else is about the same. We have 6 pistons in our engine versus a 6-piston, 6-cylinder engine. We have 6 injectors, 6 injectors. We have 6 conrods, 6 so it's basically the same, although our engine is about 20% smaller in total size because we're a 2-stroke. So we have these advantages, pros and cons, or pluses and minuses. When we do all that math, John, we end up at about somewhere between 5 and 10% cost advantage on the base engine.
Wow.
And then you talk about now after treatment, our engine runs cleaner, right? We have less soot coming out of the engine. We have lower NOx. Our hydrocarbons and CO are great, so we're very much in the ballpark there. And when we put the after treatment on, we can make those smaller also. I don't have a figure for you on that, but it's in the right direction. And now that contrasts with what's happening with other engines. If you take a conventional diesel engine and you say, how are we going to make this better? They want to add variable valve timing. They want to add waste heat recovery. They want to take the fuel pressures up from 2,000 bar to 3,000 bar. It's all adds. They're adding, going from 1 turbocharger to 2 turbochargers to 3 turbochargers. Some of those are already in production. 3 turbochargers with high cylinder pressures. So that all adds cost. So the cost of the comparator engine, the conventional engine, is going up, and ours is the same or going down as we develop the engine.
So what sorts of durability and reliability tests have you run on your engine? I mean, one of the things that people think about diesels, they last forever, right? I mean, and
that's the legacy of the diesel, no doubt about it. It does have some advantages that make it that they run cooler than gasoline engines, as an example. Diesel engines do. I would say, as a general, we have not done all the durability that needs to be done to go to production, which is why I'm not telling you about a production engine tomorrow, right? We will not go to production. We will not go to production until we run all those durability tests. But let me tell you, the chief technical officer of my company, Achates Power, John Kosnick, is a 29-year veteran of Ford Motor Company, went on to work at Case New Holland and FUV. Super guy. He knows engines inside and out. He ran V engine engineering at Ford Motor Company. Right, so these are the kind of talents that I bring into the company to make sure that we do it right.
And you've got a great automotive background yourself, too.
I'm trying to catch up to John.
Hey, we've got a number of questions coming in. Dr. Botox wants to know, will this new engine be hurt more by carbon buildup?
No, I don't believe so. I don't think there's any unique challenge associated. One of the things that we think about on our engine is, okay, it's a different engine than a conventional engine. What unique problems are we going to have? And to my knowledge, I would say no. I don't know of any carbon buildup problem that's unique.
Carl's
As an example, one of the things we eliminate the cylinder head gasket. So all those cylinder head gasket problems you've had on engines in the past with coolant leaks, we don't have that problem. We don't have a cylinder head gasket. So we think about those unique things.
Yeah. Carl wants to know, how does the Achates engine differ from eco motors?
Okay, in a very important way. The important thing about our engine is we have 2 pistons in a row, like you saw in the animation. But in the eco motors engine, they have the opposed piston, opposed cylinder. So they actually have a cylinder over here and a cylinder over here, each with 2 pistons in it. So if you line them up, it's 4 pistons in a row. And so you can see you just end up with a very wide engine, or if you put it in a car, you end up with a very tall engine, or somewhere there's this awkward dimension that basically doesn't fit in today's vehicles. So that's a real challenge for them. And as a result, they have to reduce their stroke, which is bad for efficiency, bad for breathing. That's a real challenge. So that's, I would say, the most important thing.
So your approach basically keeps the same overall engine architecture if we sort of squint our eyes.
You know, what I like to do, Gary, is I like to picture a 6-cylinder inline engine, a nice 6-cylinder inline engine, and just saw that in half, throw away the cylinder heads, and flip that one half on top of the other, and you can immediately get the image of what our engine looks like. Now, when we do that, we also downsize the engine by about 1/3, and so it shrinks some, right? So in total, it's a smaller engine, but that dimension across those 2 pistons does tend to be a larger dimension.
So instead of being a wide engine, it's a tall engine.
It's tall. Now, we run, our military engine's running in a horizontal, it's flat. It's
right.
lying down. Come on, thanks. And then we have our commercial engines, they stand up, and some we tilt. So, you know, there's lots of different configurations for engines in terms of how they get installed in vehicles. What we've found is that we've done the studies, so we have our customers send us the CAD for their, the designs, the data for their vehicles.
Engine compartments.
Engine compartment data. And then we basically design an engine to fit in their engine compartment, so they don't have to change their vehicle. And we do that time and time again. It's no problem. We can make it fit.
Hey, we've got a phone call here. Ben, let's bring in that phoner.
Hey guys, this is Young Blood calling from Cleveland, Ohio. I'm
All
an
right.
old-timer gearhead, and I grew up with diesels. My dad was a man-of-walk crane operator, operating a magnet crane in the steel mills when I was just a little shit. And he put me behind the seat, and I grew up smelling Detroit diesel 2-stroke fumes. So I know what they smell like, and then I got older and I learned how to rebuild them. I'm very familiar with 2-stroke old-school Detroit diesels.
Yep.
Mr. Johnson, my question to you is, gasoline engines make more horsepower than torque. Diesel engines inherently make more torque than horsepower. Where is your new generation 2-stroke diesel fall in? And what are we looking at horsepower-wise when it will be applicable to industry like light trucks or automotive application? Horsepower and torque. Great show, great product. Thanks, guys. Bye.
Sure. Thanks.
It's a great question, right? So what we're doing when we design the engine, any given engine for any given customer, is we design it to meet their requirements. And in most cases, we're going into a place where there's already a diesel engine. We do have a couple projects that are chinning against gasoline engines, and we face that same differential that the caller talked about, the difference between, you get more torque on a diesel engine and less power. In terms of power density. But the power densities on diesel engines also have been going up over the years. So it used to be all they could do was pull stumps, and then you'd pass them going up the hill because they had no power to get up the hill. But really, with modern turbocharging and charge air cooling and electronic, direct fuel injection and all the technologies that Detroit diesel engine did not have, and I think that's one of the secrets of our company is that we've basically been applying technologies that have been developed for 4-stroke engines onto the opposed-piston 2-stroke engine and basically revolutionizing it in that way. So, once you apply that, this is going to be a great driving engine. So what do you want? What kind of power and torque do you want? We'll make an engine for you, no problem.
Okay, and that segues perfectly to the last question here. Barney wants to know, how long before your engine is ready to go into a passenger car?
So you think about the regulations the industry's facing. And between 2020 and 2025, there's going to have to be some revolutionary engines in production for OEMs to meet their requirements. So that's the time frame that I predict. The actual announcements are going to come from my customers, so I have to hold back on that. But it's around the corner. It's not far away now.
Wow, that's way cool.
And Dave, the last time I can think of an engine design that the IP resided somewhere else was the Wankel. Back in the 70s. A number of companies bought manufacturing rights to that, did different versions of it, but since then it's all been kind of in-house. Engine design comes from in-house. If I was an automaker, what kind of deal would I have? Would you guys be selling basic intellectual property to this? I mean, Achates doesn't want to be an engine maker, right?
Yeah, we're not interested in the engine making business. I like that business personally, but that's not what the company is set up to do. We've developed this technology and we were partnering with these companies. So the customers that we work with, like Fairbanks Morris, not for a vehicle, but nonetheless the same kind of thing, we've licensed our technology to them so they can go build engines using our technology and sell those engines to their customers. And their customers are going to be very happy because they're going to more than meet emissions, they're going to have more power, they're going to have better fuel efficiency, and so they're going to have a successful business based on that.
That's so cool. This is a great story. You're a great spokesperson for this effort, and you really do know engines and the whole thing that you're getting into with it. Thanks so much for coming back. We're going to have you back in the future, too, because this is too exciting, too. So, yeah, David Johnson, CEO of Achates Power, thanks so much for coming on Autoline After Hours.
My pleasure. Thank you. Thank you.
Thanks,
Cool. Yeah.
Pleasure.
And we're going to take another quick break here. We'll be back talking about some more of the news and things that we've been doing here.
Have you seen what's been happening with our other shows? Here's this week's Auto Lineup. We start with that fascinating story about the alleged bugging of former Ford communications chief Jason Vines by his own company at the time. Then John gave us his Autoline insight on those Consumer Report rankings on the best and worst infotainment systems. And finally, we showed you those hilarious Jim Carrey Saturday Night Live Lincoln ads spoofing the successful Matthew McConaughey MKC commercials. For more details on these stories and others, check out our website or click on our YouTube channel. Hey, and don't forget our latest episode of Autoline this week with the aforementioned Jason Vines, where he talks about that bugging incident and other parts of his long, storied automotive career in his new book. All that and more on Autoline.tv.
I really like what David Johnson's talking about, and I thought he made such a good point that as you try to make current diesels or gasoline engines more efficient, you're adding. And, you know, I thought his point was spot on about the hybrids, too. You know, it's, again, you're adding. And so to me, to be able to say, hey, we've got a new engine here and it's 5 to 10% cheaper, to, I think, the average consumer, that wouldn't sound like much. As you guys know in this business, that would be a huge savings.
I just wonder, though, I mean, we all know the mentalities within big companies in terms of not invented here. And again, looking back, I mean, aside from Wankel, there really hasn't been a disruptive powertrain technology come into the business other than electrification in terms of combustion engines. So we'll have to see really where this plays out.
And do we count the Wankel as being disruptive? I mean,
well,
it really was rather minor.
Looking back on it, but if you look at 1970s, everybody and his brother had a Wankel program.
Right.
And the investment looked like it was going to go that way, but then early 70s emissions regs came in and kind of killed it. So,
you know, and the other part of that, though, was that, you know, to the point of making these things, I mean, it was very tricky to machine the trochoidal shape of that.
Right.
And I listened to this
to seal it.
And I just got to wonder whether or not there isn't some very complex casting that needs to go on for the piston, as well as some very sophisticated machining to make that shape, you know, some 5-axis machining of that, and in addition to which they may have to do some sort of a plasma coating or something on the head of that piston, because I mean, if that's, you know, they're going up against one another, so you're constantly, you know, fire. So there could be lots of additive costs in terms of process.
But his point's a good one in that, you know, once you get into the 2020 to 2025, you know, with CAFE standards or even the CO2 standard in Europe, yowza, it gets real tough.
Sure.
And it's not stopping at 55 mpg. I mean, it's going to continue to go.
Right.
So,
well, we'll see. as I keep pointing out, I saw gasoline priced at $2.87 a gallon.
Yeah, I
morning.
saw on Gas Buddy that more than that it's below $3 a gallon and practically everywhere.
$2.89.
But speaking of engines, we had Larry Nitz on the show a few weeks ago, and he's with General Motors and very involved in the Volt program, and so we had the opportunity to see some of the new technology for the Volt, and boy, I'll tell you, those guys are just
hammering it.
Very, very, very
So they just
dedicated.
released some things. They've taken 100 pounds out of the electric motors.
Took over 100 pounds out of the whole drivetrain, basically.
And 30 pounds out of the battery pack.
30 pounds out of the battery pack.
That's
huge. And we don't
Right.
know what's been taken out of the car.
Right.
So,
Right.
Yeah, so this is purely the powertrain situation, and they're going to be building the Voltec power packs in Warren, Michigan, and transmission plant because basically you look at this thing, and it's very much like a transmission, and so they had us build this. Remember,
Right.
Lindsay was there, and
Yeah.
so these guys are and to the issue of what consumers want. They were saying that this is basically the most researched car in existence because 60% of Volt owners are anonymously providing data over OnStar that General Motors has, so they're able to see all the behavior of the drivers in terms of when they're charging, how often they're charging, how much they're using the engine, how much they're not using the engine, and it's really quite astonishing.
When's the new one come out? I know they're showing it at the Detroit Auto Show in January.
yeah, it's a
but what's it gonna
16
be?
model. It's late summer 15
Oh, really?
is launch.
Okay,
Yeah.
so that's not too bad.
So it's coming along.
About
right.
6 months after the debut at the auto show.
And they're talking 5 to 12% efficiency across the powertrain, which you could telegraph into efficiency for the vehicle, up to 12%.
They're not saying, but they've redesigned the whole thing. They gave us a little rubber cap that they put on the Voltec to ship it to the plant. They said that's the only carryover part. Everything is.
This is a significant revamp, and you've got to look at the investment from the top of General Motors to say, I mean, yeah, it's been 5 years, but to say basically redo everything.
Yeah.
I mean, LG Chem, the cells are different, the Voltec system's different, all new internal combustion engine, cooled EGR, as Dave was talking about. So they threw a ton of money at this thing.
The engine is bigger, so they're going from a 1.4 to a 1.5, but they said that they've discovered that that's actually far more efficient than if they'd kept the smaller engine.
Right.
Which sort of seems counterproductive.
But now they got to get this drivetrain into more than the ELR, which is basically an invisible car, and into small CUVs and passenger vehicles and so forth. Volt sold what? They said 69,000 cars since
in 5 years.
late 2011. It's
Right.
nothing.
They lost a fortune on the car.
Right.
But, I don't see where they've got a choice. They've got to keep plugging ahead on this.
No question. Yeah.
And so last week I wasn't here because I was in Wolfsburg, Germany.
Yeah. Tell us,
And
driving their electric car,
So I was driving the e-Golf and I was driving the GTE. And you remember we had Oliver Schmidt on the show from Volkswagen a couple months ago, I believe. And and he was playing very coy about what their plans were for the GTD, the diesel version of the GTI, and so now they have the hot hatch version, which is a.
So what'd you think? Because he said, "Oh, it's as fun to drive as a GTI."
I'll tell you, it is a blast.
Really?
It is. Because again, it's all about low end torque, right?
Sure.
Right.
And so what do you want when you're pulling away from a light, right? And you just hammer that thing and it just goes. It's got an internal combustion engine and. The battery pack on the GTE, then the e-Golf, which they just came out with numbers with saying that in the compact electric car arena, it's the most fuel efficient of any car, getting 126 city, 105 highway, and 116 combined MPGe.
Right.
But this is the pure electric.
Pure electric.
Right,
And that one too, had that on the Autobahn and, had my foot to the floor and kept up with traffic quite well.
So go back to the GTE. I guess I don't get. That's a hybrid,
It's
or
a hybrid.
Okay.
Right. So, but it's a plug-in hybrid. So you have and it's one of those things of range depends on how aggressive you are on the throttle and so on and so forth. But it will drive pure electric for a limited period of time. and but otherwise it's as you know, a normal hybrid. And what I thought was interesting is that, okay, so these are Golfs, right? And Golf is basically Volkswagen. I mean, that's what they're about. And so the Wolfsburg plant, the legendary Wolfsburg plant, which I discovered, the outside walls now are basically historic structures and cannot be changed. So Volkswagen can't screw it.
Because they go back to 1944 or 5.
And so within the plant, they have a special area where they're basically hand building the e-Golf. Okay, it's you know, so they take the vehicle off the line, and they're making a big effort to explain the MQB, which we've talked about on the show before, their modular build program, and basically saying that, you know, we designed this Golf knowing full well that we would put in internal combustion engines, we'd put in diesels, we'd put in, you know, battery packs, and we would also put in battery packs for hybrid vehicles. So what they're doing is they're making this special area where they have these technicians who are, you know, a couple of guys are building these cars. It's a very slow build, but they're saying what they want to do is have complete understanding and knowledge, because they're going to roll this into what Audi is doing and the other brands. They're, you know, they have plans for other electric vehicles. They've got a plant they took us down to in Braunschweig where they're making the battery packs. I mean, it's these guys are serious about this stuff.
It reminds me of a Larry Burns saying, "Think big, start small, learn fast." And it sounds like what they're doing with this.
It was quite fascinating. And,
But you know, it's interesting to hear Gary say this, because it wasn't long ago we were all hearing the Germans, you know, when Prius came out, when Insight came out, when Ford was messing around with hybrid escapes, that this hybridization, this electrification, the diesel's going to carry the day. So very interesting.
Yeah. Hey, we're going to take another quick break here, but let's get back to this discussion right after this.
Are we on mic during this?
I don't know.
Yeah. Sounds like Wild Thing.
I was just thinking, is there going to be a commercial? Oh, I guess we have. Not the truck.
Nice. Not nice.
The new Elantra from Hyundai. Nice.
You already know that you can listen to Autoline's Industry Insight in places like YouTube and Stitcher, but did you know that you can also listen to it live in your car? It's simple. Just pair your smartphone with your vehicle's Bluetooth connection or plug into the aux jack. Then navigate to Autoline.tv using your phone's browser. Find the show you want to hear and click play, just like you would on your computer. This is Autoline After Hours with John McElroy. It's that easy. Never be disconnected from Autoline's top-notch insider information with Autoline on the go. Want to really thank our friends at Hyundai for supporting this show, because without that kind of support, we can't have these kinds of great programs. Hey, I got to tell you guys about my lunch yesterday. I had lunch with Dan Gurney, who was in town.
A hero of mine.
Yeah, a hero of mine, too. I mean, just an amazing guy. He was in town because the Henry Ford Museum gives out this award. I think it's the Henry Ford Museum.
It was,
It's called the Edison Ford Award, and it's given to people, you know, for a lot of creativity, innovation, really making things happen and all. He's only the second recipient. The first was Dr. W. Edwards Deming, you know, the guy who really introduced quality systems to Japan and transformed the way they do things there. And even though he was an American, it took him a long time to get recognized in this country. But I think in 20 years, they've only given out this award twice, and Dan Gurney was the second recipient. But so there was a very small group of us that got to have lunch with him yesterday. And so my first question to him was, is it true that you're the guy who started this tradition that after somebody wins a race, they get the champagne and they spray everybody with it? And he says, I believe it's true. In fact, all of our research shows that it's true.
Wow.
So apparently they really went out of their way to find out if this was true. And I said, so how did it all start? And he said, well, it started at the 1967 Le Mans race. He said, this was the 10th race for me. 10 times I've been trying to win this thing. Finally won it, with A.J. Foyt.
GT40.
Ford was there in force to really just shove it down Ferrari's throat, show that they can do it. So it was a really big deal. He says, we're standing up on the winner's platform, and there's all these people down there looking up at us, with cameras and everything. And he says, somebody comes along and hands me this big magnum of champagne, and I'm looking at all these people, the photographers, looking expectantly. So I start spraying them with it. And then I turn around and spray everybody on the platform with it. And sure enough, from that point on, I swear to God, every race, whether it's champagne like they use in Formula One, or if it's, somebody getting sponsored by Pepsi in NASCAR, spraying everybody with Pepsi or whatever it is, it all started with Dan Gurney.
But you can't spray people with milk, so Indy won't.
So he gets this award. Now, I was surprised that he got the award, but he didn't get the award for being a racer, right? He got the award for being a technologist, for contributing to things like, the rolling wind tunnel. And that really surprised me. I had no idea that he was involved in technology to that extent.
Oh, yeah. Well, he had raced for a lot of big teams. Ferrari, Porsche, BRM, I'm blanking out on the others, before he started doing his own team, building his own cars.
All-American Racing.
All-American Racing. He's still the only American who's ever won a Formula One car in a car that he designed and engineered pretty much himself, with some help, but did it himself. He ran a lot of racing programs, not just with Ford, but with Toyota as well. Right. Did a lot of innovation. I mean, still the wicker or the Gurney flap, as it's, came about because Dan Gurney was the first to use that.
Right. Also, the Gurney bubble. If you look at some GT racing cars, he was so tall, Enzo Ferrari called him my big Marine. And he's big in a car. And, to get the car down low, generally these cars that he drove in had kind of a blister on the top roof panel for his helmet to fit in. So, as a matter of fact, the first Viper coupe was given 2 Gurney bubbles just to replicate that.
Exactly right.
To develop the Gurney Gator motorcycle, which was a very innovative kind of a kneeler kind of bike, very low. Built a few of them.
No, he's an amazing guy. He's 83 years old. He's still really sharp. He might forget a name here or there, but that's about it. I mean, the guy is totally on top of things. And it was real interesting. We were asking him, what he thinks about where motor racing is today and all, because as you guys know, attendance is on the decline. TV viewership is on the decline. He wants to get rid of wings. He thinks that you got to get back to pure driving, and that these aerodynamic devices have actually been a hindrance to motor racing. I find that intriguing. That here's Dan Gurney, the guy who pioneered a lot of aerodynamics, saying let's get rid of these wings.
But I mean, isn't part of the thing that we like to see races that are fast, that people are going very fast, and so by having the wings and other aerodynamic ground effects packages, that it allows the vehicles to go faster, and if you took them away, the cars would go slower.
I don't think you can get rid of that. Kind of like you can't get rid of automatic weapons and go back to blunderbusses. I mean, once human innovation starts, it's the interesting thing about him is he survived that just carnage period in sports car racing and Formula One racing, where guys were, you could just go on and on about the people that died in F1
Every year,
cars.
people were getting killed.
I mean, this is back when you could see about 3/4 of the driver in the car, and it was great to watch them because you could see him working in the car before belt lines came up and before Hans devices and full roll cages, and now you can kind of see the top of the driver's helmet, and that's about it.
In fact, they're talking about going to full cockpit, bubble cockpits, canopies in Formula One.
And Dan, here's this big guy again, and he survived that period where almost every race these guys were dying. Lauda had his bad fire, et cetera, et cetera. So I think his voice probably carries some weight in the community in that regard.
Yeah, it really does. But that's one of the great things about this job, man, is, get to go and hang out with Dan Gurney for a couple of hours on a day. Really good.
Special.
Yeah, definitely a hero.
And you had an interesting lunch. You were
I had a lunch with Ford's global design team. So Maury Callum was there, Chris Svensson, who we've had on the show here, who is the design director for the Americas, Joel Piakowski, who design director of Ford of Europe, Martin Smith, who will be retiring from Ford of Europe job, but staying in Ford, helping Joel with the transition. And
interesting.
he said, I'll be around, don't worry. They brought Freeman Thomas in from the Advanced Studio in California. They had Todd Willing, design director, Asia Pacific, who had some very interesting observations about the China market. Amco Lienhartz, design director of Global Interiors, very interesting guy. David Woodhouse, who is the design director for Lincoln, and very, very interesting to talk to him. Craig Metros, the exterior design director of the Americas, and Stefan Lamb, exterior design director of Ford of Europe. So they all got together. They come together someplace in the world at least 3 times a year, and they trade ideas. Apparently, they spent a couple of days at Steelcase, in
the
Holland,
furniture
Michigan,
maker.
the furniture maker on the other side of Michigan. And I said, so, why did you do that? Was it about the aesthetic? Did you see something about the design aesthetic? And they said, no, we wanted to learn more about the process. That apparently a Ford board member is a retired Steelcase guy who has long been a champion of design within Steelcase. And so he suggested to these guys that they might want to spend some time and see the processes that are going on at Steelcase. And they seem to be very intrigued about what they saw and trying to apply that to what they're doing. But of course, Lincoln being big in the news this week with that Reuters report about the potential $5 billion investment between now and 2019 in terms of developing that new platform. What do you guys think about that?
Well, I think they're going to need a lot of money and a lot of time.
Is $5 billion enough?
Boy, I don't know. I mean, obviously they're looking at China. I mean, that's everybody's pot of gold is China for Lincoln. And I think they probably think of Lincoln as Abraham Lincoln over in China. I mean, the caricature could be a car with a stovepipe hat,
Need a Gurney bubble.
Yeah, and we talked a little bit earlier when Dave was here about really what it's taken Cadillac to get to where they are, which probably, according to the Germans, they're still not there. According to us, the product is there, but they don't let the customer know, they don't market it, et cetera. What's it going to take for Lincoln, which is behind even Cadillac in North America, to become a globally recognized brand and not become an Acura? That's nothing wrong with Acura, but Acura kind of never fit the Lexus Infiniti. It was never a headlight-to-headlight competitor. So it's cubic money. I don't know what $7 billion. You said $7 billion, $5 billion. I don't know what that is. I mean, we all know an assembly plant and the lines to build cars in an assembly plant it's $1 billion.
Right.
Look, I think this is a great move. Not that they run the company based on what I said, but then when they asked my opinion, I said, look, if you're not ready to spend $1 billion a year for the next 20 years, don't even get started on trying to turn Lincoln around. Yeah. And so the fact that they're spending $5 billion in 5 years is the billion a year number that I want to see. I think it's real smart to have a 5-year plan, see what you can get done in that time, figure out what you've got to do for the following 5-year plan. But there's no question that Ford Motor Company desperately needs to have a luxury brand. They're sliding down the list of automakers when you rank them by revenue and profit. A key reason is that they don't have that luxury brand that can really generate the profits. Remember, this was all supposed to be the premier automotive group of Jaguar, Land Rover, Volvo, Aston Martin. That was going to be it. Well, that's gone. And I don't think going forward, and by going forward, I mean going deep into the following decade, you can survive just as a mass market brand. I think you're going to get your teeth kicked in or you're going to get bought out by somebody else. Ford needs to do it. I'm so pleased to see that they're putting up real money.
But it's interesting. The report said that basically that this D6 platform would be for an MKZ replacement, MKZ midsize car. Now, isn't the standard logic that every luxury car builder needs a large, S-Class vehicle? Flagship?
Yeah. Sure they do. But those big flagship vehicles sell in very small numbers. Mercedes doesn't sell a whole lot of S-Classes. and you've got to be able to sell them globally to get the volume to justify that. So to plunge head first, like Cadillac's going to do with this D6, is it? The big one?
Right.
Is a very risky approach. Going for a big CT6, excuse me.
New nomenclature.
Yeah. But anyway, at this point, in my opinion, for Lincoln to go into a really big sedan that's going to sell in very small numbers, they're not ready yet. Maybe at the end of this 5-year plan is the time to start thinking
but
of
the
that.
question, it goes back to what Lindsay was saying about Acura, not really getting there. And so over this 5-year period of time, is Lincoln going to sort of be this Acura type vehicle because it doesn't have the big car? It doesn't have the street cred because remember when Infiniti came out, it was the LS. The LS 400 was their first car, big car.
Lexus.
Yeah.
Right. No, you're absolutely right. It was. And they probably lost a big amount of money on it, too, as they built up this Lexus brand, which still, by and large, is just an American brand. It's not much of anything in Europe or Japan or China.
And despite its breadth, is RX and ES. I mean, RX really is the heart of this luxury brand.
40% of the sale.
You forget about the LS sedan. You really do,
But and Lincoln also had the big thing this week with the Matthew McConaughey, Jim Carrey ad on Saturday Night Live.
You should play some of that stuff.
But which has probably been eclipsed by the Chevrolet ad, which I think we
wasn't an ad. So a little bit of background, in the United States. Well, we're showing. Let's run this Jim Carrey parody of the Lincoln ad.
Go back to actually move forward, and I don't mean go back and reminisce or chase ghosts. I mean, take a big step back, like go from winning an Oscar to doing a car commercial. My agent was like, I could understand if you did this right after the Lincoln Lawyer. That would have made sense. But you don't buy a Lincoln because it makes sense. You do it because...
Yeah. So great parody, and boy, this is just one of many parodies of that set of commercials. So, and let's get into the Chevy thing in a minute. Is this good or bad for Lincoln, having so many people make fun of the ads?
Well, and get into the Chevy thing. I mean, you've got to make lemonade if you've got lemons. I mean, that isn't a lemon car, but you're talking about where this money is going to go. Brand new Mustang platform, that's got to be used for something else. You look at the Lexus strategy and the Honda strategy is they're building luxury cars off of pedestrian platforms. Ford is going to do that. I mean, you can say a platform's a little bit different, but you guys know better than anybody else. The hard points are the same. It goes down the line the same. It's shingled very, very much the same. So where does all that money go to? Does it go to just enhancing the brand? Does it go to interiors that are just, real animal hide versus pseudo animal hide? Because underneath, they're not going to have Lincoln engines, despite the Lincoln Motor Car Company. They're not going to have Lincoln black metal. It's all going to be Ford.
Right. But this ad and the, Ellen did a parody, and I think Fallon did a parody.
It's taking a hit.
The official word that Lincoln's like, everybody's talking about us. We've never been in the conversation. Isn't this great? We're in the conversation. But you know what? Would you want to be in a conversation about Lindsay Lohan? You know what I mean? It's just, it's just like, I want to buy that car that Jim Carrey was making fun of while he was rolling a booger. I mean, it's just, I don't see it good for them.
Yeah. So let's jump to the Chevy one and just...
But real quickly, though, Lincoln Motor Company, does that resonate with you guys? Is it
Lincoln Motor Car Company.
The Lincoln Motor Car Company. Is it believable at this point?
If I was born in the 30s.
Yeah. I think it will become so. It's not yet. And they named it before they did anything. But to me, for them to appoint Kumar Kalhotra as the guy to run it, I think is really smart. He's a hardcore engineer. He's got a lot of global experience. Now we're learning that he's getting $1 billion a year budget to go out and do it right. I take this as all really good moves.
Although it seems that let's be a little cautious here, because it seems, according to Reuters, it was 2.5 will be for the development and then 2.5 for other stuff.
Well, that's okay.
So like maybe more Matthew McConaughey ads.
Well, that's my point. Yeah.
You got to get out and market the stuff. You got to go out and do special events. You've got to be seen. You know, you've got to do things not just on television and radio and magazines and all that. You've got to go out and have this special touch. You've got to put a bunch of it to dealerships, especially in China right now too. So I'm not going to nitpick exactly where the dollars are going. You know, as somebody who wants to see them succeed, I think they're doing the right thing. I think they're going about it the right way. And at some point, I would love to see them break that operation out of Ford entirely, physically.
Didn't they try that? PAG?
Well, yeah, Premier Automotive Group, but that was just all the marketing people. You know, I want to see, just as Audi is truly a standalone company within the Volkswagen Group with its own board of directors, annual report, P&L, and all that, I'd love to see the same sort of thing happen with Lincoln.
And John, you think the move to New York is a good idea?
I think it's a good idea because Johan de Nysschen has got, for Cadillac in this case, not for Lincoln, but he's got to show he is in charge. If he's down at the Ren Center, you know, the GM headquarters, and all his people are coming in every day, they're thinking GM. They're thinking, what's Mary doing today? What's Mark Royce doing? What's Dan Ammon doing? No, they got to be thinking about what's on Johan's mind. And they've got to get out of that environment to really start doing things differently. My prediction is they'll be back, you know, but for Johan to show, I'm in charge here, I'm driving it, I'm going to really make this brand resonate amongst luxury buyers. I think it's a good move.
How does that differ than PAG, as Gary was saying, in Irvine, California?
Or how's that Shanghai thing working out for Infiniti?
Well, you know, look.
It's like we're moving from Japan. And
right. Look, these things don't happen overnight. And, you know, I love telling the story that in the late 1920s, when Cadillac set up to knock off Packard as the recognized luxury brand. And there was no Mercedes, there was no BMW, Audi, Lexus, none of that. It was pretty much Cadillac and Packard. Lincoln was a nobody at that point. It still took Cadillac 20 years to do it. 20 years, and they threw everything in the kitchen sink at it. You know, luxury, as you guys know, it's not just about having great product. If it was great product, I mean, Cadillac, I think, is there with the ATS and the CTS. You have to have heritage. You have to have brand credibility. That can only be built up over time. So, yeah, I'm not going to criticize Infiniti for having headquarters in Singapore and not having a miraculous, you know, revival. Give it time. I still think...
Wait till every Catera on the road is in the junkyard. I saw one the other day. And I know what you're saying, and it's like, you know, I just gotten out of an ATS, and you're thinking, God, these cars are great, et cetera. This moved to New York, and then it's like, oh, God, I forgot about that, you know?
That's right. Thank God there's no Cimarrons out there.
The caddy that zigs, They had Cindy Crawford there ahead of their time on that one.
Yeah, that's right.
But they got rid of the ducks, and so remember they had the duck going the wrong way?
It was lame.
So we got to see the Chevy thing.
Oh, yeah. So let's run a little bit of that Chevy thing. Well, we'll end the show on this.
Painful.
Thanks, Madison. Congratulations. As the official sponsor or the official vehicle of Major League Baseball, Chevrolet is proud to participate in this prestigious award. Along with our dealers, we are also extremely honored to give back to this sport by supporting baseball in cities and towns across this nation. At Chevrolet, we have...
you better look at my notes. What am I going to say here?
And greatest technology in our truck lineup, which is the all-new 2015 Chevy Colorado. It combines class-winning and leading, you know, technology and stuff with Wi-Fi powered by OnStar.
Yeah.
All right. So this gets back to your question, John. Does that do Chevy good or bad? Is this going to be problematic for the launch of the Colorado, or is it going to do great things for it?
Well, here's the background. Okay, so you know, the World Series, you know, San Francisco wins it yet again in a nail biter of a game, very end, you know, incredible series. And so this guy gets up to give the most valuable player award.
Madison Bumgarner.
Yeah, right, who pitched a hell of a game.
Right, amazing.
Amazing game. But he doesn't get a Corvette. He doesn't get a Camaro. He gets the
mid-size pickup.
The mid-size pickup. And it's not the president of General Motors or the chairman of General Motors. It's the local regional sales guy from Kansas City who can't even keep to script and says, oh, it's full, this truck has got technology and stuff, and it's gone viral. This little clip that we just played here, it's every sports show in the country is talking about it. It went crazy on Twitter. So so
who's had a worse week, Lincoln or Chevy?
Well, I think Chevy did a smart thing. They knew that this was terrible, but they've embraced it.
Lemonade from lemons.
Yeah, exactly. So they've embraced it, and there's even a hashtag out now called #technology and stuff. Everyone's talking about the Chevy guy, so Chevrolet has kind of embraced it. They're making fun of it too. Lincoln hasn't done that at all. And, and now, this is a month of parodies we've had of these Lincoln ads. I think Chevy did the right thing embracing this thing. I think Lincoln's got an issue. We'll see if it really has. Because really the parodies are making fun of Michael McConaughey. Or Matthew McConaughey.
And that ad's been out for a while. And so SNL scriptwriters got down and crafted that brilliant script that Jim Carrey said. This guy was on the spot. Somehow he was this regional manager was tossed into the cauldron. Wrong guy for the job.
Who tossed him in there?
Yeah.
I mean, come on. You can't blame this guy for, freezing in front of a national audience.
That's exactly right. This was the discussion down at the Tubes today is how did this happen?
Yeah. It's like, oh, it's a surprise. Somebody's going to win the World Series in the 7th game.
Yeah.
Let's not send somebody from headquarters to deliver this. Let's not make a big deal out of it. We'll just, call the local guy. He'll bring one down to the stadium. He probably had one on his lot.
And, to your point about a Corvette, you'd think that this guy would get a Corvette. Why didn't they give him 2 trucks? A his and hers truck or
both, a vet and a truck.
And
a Colorado.
A vet and a truck, something like that,
That's the old GM.
Yeah.
Come on.
Hey, look, let's wrap this up here, guys, but great discussion. I mean, we've been all over the place with these things, but Achates Power, very interesting. I can't wait to see these guys put these things in production. So, Lindsay Brooke, thanks for coming on.
Thanks, John. It's always a blast. Thanks, Gary.
Lindsay.
And let's do it again next week.
Next week.
We'll do it again, too. And want to thank all of you for having tuned in.
Autoline After Hours is brought to you by Bridgestone, your journey, our passion. And by Hyundai. See what makes Elantra so nice. Check out its style, interior space, fuel economy, and popular features now.
Visit our website, Autoline.tv, where you can watch us live Thursday nights at 6 p.m. Eastern. Get your daily news fix with Autoline Daily and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.